Okay, thank you for joining us for the webinar, Kelway Prepares for Expansion by Turbocharging XenApp Performance. We're lucky today to have Jonathan Eaton-Williams, who's the practice lead for end-user computing at Kelway, which is one of the largest Citrix Platinum resellers and consulting partners in Europe, based and headquartered in the UK. A couple of logistical notes before we get started. The slides and recording will be available on the Atlantis Computing website after the webinar, likely tomorrow. In terms of questions, if you have questions based on Jonathan's presentation, you can submit them via the questions box in the GoToWebinar console. And we'll answer some of those questions throughout the webinar, and then we will pose some of them directly to Jonathan at the end of the session, and he can answer them directly. With that, I'm going to turn over the session to Jonathan and let him get started by sharing his screen and start the presentation.
Okay, thanks, Seth. Hi, Seth, you can hear me, I take it? And then,
yes, we can hear you fine. Thanks.
Thanks for the intro, Seth. Yep, as Seth said, I'm Jonathan Eaton-Williams. I look after end-user computing at Kelway. In terms of me, I've been doing kind of Citrix and application delivery for quite some time. I think it's even more than 15 years now. It certainly seems like at least 15 years. I certainly remember installing Citrix WinFrame all those years ago anyway. I guess the sort of core skill set I have is around delivering XenApp, delivering applications to end users, and the kind of surrounding tool sets that you'd expect around there. And I'm sure a lot of the guys that are attending have got some similar backgrounds there. Just a quick note about who I work for. I work for Kelway. We're based in the UK, though we have about 20% of our revenue comes from international work. That's typically quite specialized in the Middle East and Far East and South Africa and what have you. We're about 950 to 1,000 people, depending on who you ask. And it's probably more like 400 or so in technical and support roles. And so a lot of our business is solutions focused. It wasn't beforehand. We used to do a lot of supply, but over the last 3 or 4 years, it's changed around rapidly. Anyway, to the bits that are a bit more interesting. So we are a sort of eat-your-own dog food organization in the sense that we run Citrix XenApp for all of our end users. Well, I want to say all. Obviously, there's some people that don't get to do that. We've got some people in marketing that don't. A few guys that have got laptops as well. But by default, we have a no laptop policy for all our sales guys, and pretty well for our technical guys. It's only if they require them. So about 95% of our user access, we reckon, is running out of Citrix XenApp. We've experienced some challenges with it earlier on this year, which I'm going to talk to you about today. And the perception from the end users were poor, and I'm sure many of you who've got Citrix fronting up your end user experience, you will know that Citrix gets the blame for everything. And so people would blame Citrix if they got unpredictable experience, but blame Citrix if things weren't working out the way that they thought they should. And frankly, they'd blame Citrix for anything that went wrong. Yeah, that's kind of fair enough. If you've been working in this field for a while, it might well have been Citrix. But we had an unprecedented number of calls and people complaining earlier on this year. We've got quite a lot of salespeople. They get grumpy very easily, particularly when they can't sell things and make lots of money. And so we felt a bit of pressure to do something about this. And another thing that was happening is we were in the process of acquiring another company and about a 20% increase in the number of seats. I think we came to the conclusion that we couldn't leave things as they were. And so in terms of quantifying end user perception of the service that we were giving them, things certainly got worse. This is 2013 figures. A bit of an omission on the slide, not stating which year they're in. But over January, February, March, you can see in terms of direct Citrix complaints, if you like, things were going up fairly steadily. And we were due to acquire another company at the end of March, over the Easter weekend, in fact. And it's pretty clear that if we left things as they were, then that bar was probably going to get bigger, and there were going to be more grumpy people if that were possible. And so I think it's probably worth me just clarifying what was going on there. We acquired a company called XenApp earlier on this year, and those guys, we expected about a 20% increase in concurrency on Citrix from that acquisition. That acquisition is all now complete, some 2 or 3 months ago, and so we've had to absorb them into the existing estate. And I'm sure many of you, if you're kind of existing Citrix customers, have been through this kind of M&A style stuff where you're acquiring companies and have to spin them off a desktop quickly. We actually absorbed everything of theirs over the Easter weekend. There wasn't many Easter eggs for me, but we basically between Good Friday and Easter Monday, we absorbed all of their systems and converted them all to 100% XenApp environment. With a couple, literally 1% or 2% of exceptions. So it's probably worth just to frame this for you guys, for you all, a bit of a summary of where we were. So running XenApp 6, actually, we are going to migrate to 6.5 or Zen Desktop 7's App Edition, whichever one it might be in the near term. This is XenApp 6 does what we need. We'd rather we were on 6.5, but we haven't made the move yet. We have around before the Equinet acquisition, which was at the end of May. We had about 800 total users, out of which 550 concurrent was a typical peak in a day. And those other 250 people hopefully weren't out there doing nothing. Some of them are made up of the non-Citrix users. There's a lot of people out there that are perhaps using a laptop, or they're people that's working out on site, and so that's what we'd expect them to be doing. We were running this off 8 hosts. They were BL460 G7s, 128 gig of RAM, and we were getting 14 to 15 users per VM. We could have pushed that a bit higher, but that's typically what we were doing. And those VMs were 2 to 4 vCPUs with a varied amount of RAM, actually, but typically we were basing them around about 8 to 12 gig of RAM. Hopefully, some of you, or a large portion of you who are listening, have got experience of provisioning server. We run provisioning server. It's a sort of single image management and maintenance tool that Citrix provide. Now, within that, on the reboot cycle that we had prior to implementing Atlantis, we were seeing a PBS write cache of 8 to 12 gig. It's probably worth just spending a minute or so, particularly people that aren't using PBS, about what that means. Basically, there's 8 to 12 gig of churn change data on those servers between reboot cycles, in which case on reboot they then get changed. In addition to that, we've got an 8 gig page file, which can also change, and that gets rerouted to the drive that we put the write cache on. And I'll come back to that in a little bit more depth about what we do in a short while. The servers were dual Westmere chipset hex-core X5660s. If anybody's a real big server fan, that's what they were. With about 128 gig of RAM in each. And it's running on vSphere, as I said at the top there, running on ESXi. The storage, slightly less modern platform, an EMC Clarion CX4480. It's a relatively large unit, capable of serving a relatively large amount of I/O. I think the important thing here is that we're running a very mixed workload on it. So all of our VMware estate was running on it, all of our XenApp estate, some SQL, though not all, because we run some other SQL on like local flash disks and things like that for other services. All of our CIFS traffic was running from the EMC. And Exchange, you'll notice, is not on there. We took a decision to run Exchange on a different filer at the time, because we actually didn't want to overload the EMC at the time. And so, in terms of how that looks, it looks a bit like this in terms of physical hosts. So 8 of those BL460 6-core processors with a storage with Ethernet-based storage switching, and then the Clarion at the back end. Those blades were not maxed out as such. One of the things that was a bit of a problem about the way it's laid out is that it wasn't only just Citrix XenApp workloads that were running on those blades. There was things like NetScaler and Web Interface, and some of the kind of management components are on there as well. And that's something that we chose to address during this period as well. In terms of VMware clusters, it looks a bit like this. So we've got a production cluster running, if you like, low-rent virtual machines, all the kind of things you'd expect, like DCs, like some file services, management services, and tools, and what have you. 6 hosts running that, and a Citrix cluster that was supposed to be dedicated to XenApp, but was running some other services as well. If you look at the bottom area here, in terms of the Citrix cluster, there were 5 different EMC LUNs that these were spread across. The astute amongst you will know that 5 is not an even number. So that basically 3 of those LUNs were on one storage processor on the file on the EMC, and 2 of them on another. So we'll come back to that and the differences that that made in a few short minutes. So the XenApp layout, sort of beyond the physical view, we've got some hosts running ESXi, 4.1 in that particular case. We are migrating to 5.1, but chose to keep kept the parity at that time. So running 2 PVS servers. Those PVS servers are actually connected to a TIFF share. It's a possible configuration. It keeps image management nice and simple for us. About 40 XenApp hosts, circa 40. There's sometimes a few more than that. Pretty much off a single image. We had a small use case where the guys have a slightly different image, but pretty much one image. And then the write cache is on the EMC. So just in terms of a little bit more detail about how that works, effectively the C drive is provided by PVS and is read-only. There's a write filter driver within PVS that allows you to effectively rewrite changes from there somewhere else. And those of you that are experienced with PVS know there's various options, one of which is cache on target device disk, and that's what we did here. So we had a template that's basically an empty, no C drive, that's provided by PVS, and then we're actually using an E drive. For historical reasons that I can't find out, actually, I don't know why it wasn't D. I'm guessing somebody left a CD drive or something in there. Anyway, it was running an E drive, and that E drive contains our write cache, our page file, and some persistent data, things like antivirus updates, things like event logs, things like the Citrix EdgeSite Firebird database. They all get redirected to the E drive. So most of those writes to the E drive are writes that come through the PVS filter driver, but there are some native writes there just for logging and for purposes such as that. So after this, after getting the feedback from our users that things weren't perhaps running as smoothly as we'd hoped, we did some look into this, and over the time in my time in consultancy and in the reseller channel, I've been to numerous places, and typically it's never CPU or memory that's a problem. Okay, if you had a graph of problems with Citrix over time, there'd have been a lot of printing ones in years gone by. But typically, most of the problems that we find aren't because CPUs are maxed out nowadays. Modern CPUs are very quick. Modern memory is very cheap. So unless they've been configured badly from a XenApp point of view, that typically isn't the case. But what we were finding is that end-user login time is unpredictable. As an example behind that, we typically would set ourselves a goal of end users logging in 30 seconds or less. And a lot of people, they would get that. Some of them, though, we would be talking 2 minutes occasionally, and some of them longer than that, or would even get a timeout in the worst possible case. And that kind of reflected, that peaky performance was reflected within the sessions themselves, in that sometimes applications would be very quick to respond, and sometimes they would. We took a look at, at most of the areas that you'd expect yourself to take a look at. CPU, memory, well, there doesn't seem to be anything wrong there. In terms of network bandwidth, that's both in terms of data center network bandwidth and in terms of data center to the client bandwidth. We found none of that was really contended. One of our main offices we found a year or so ago did have some fairly contended bandwidth, and we effectively tripled the bandwidth there, and that problem away. So we didn't find the answer while looking at that. Our PVS server is running Windows 2008 R2, 64-bit with quite a lot of RAM, the 2 of them are, and so we found that it wasn't contended on RAM, and there was no kind of I/O problem there between that and the TIFF share, and it was sized generally well. So from a Citrix point of view, from the ground up, it was actually configured pretty well. I think I'm probably slightly tongue-in-cheek, but Citrix UVM managing profiles fairly well. That's kind of pretty well what it does. It manages things fairly well. And it was doing that and keeping profile size down, though there was some variation between end users. And so perhaps unsurprisingly, for most of you attending this webinar, we turned our eyes to what was going on in the storage. Now, I don't know how many of you have seen this kind of thing before. This is what's called an EMC heat map. So the 2 large bars at the top are storage processor utilization. on the EMC that was hosting the XenApp traffic. Underneath that, there's an area for storage processor A and storage processor B called dirty cache pages. I'll come back to what they are later. It's not quite as exciting as they sound. And the key bit here is to see that each one of these little black boxes represents a disk. And you'll see that 4 look particularly busy compared to the others. Those are all SSD. And you can see that, unsurprisingly, red is not good, in that it's very, very busy. So there's some red here. You can see the mouse. And there's some red up here. Blue means it's not doing a lot. And if you look at this period here, we're basically looking at ramp up in the morning, during the working day, log off time, and then down we go. So you can see we've got a large number of disks, but not many of them doing it. These ones down here are hosting some SIF shares. These ones that have got a reasonable amount of traffic workload on them. And sure enough, that's where users' profiles are stored. So we were sized to capacity rather than size to performance in the way that this was laid out. And so we did a bit of analysis on the I/O. So we checked about the fast cache stuff within EMC, and sure enough, it was enabled for the Citrix runs. You can see that by how badly hammered they were getting on that heat map. The key metric that we were looking at within each VM session was average time per read and per write. So this is how long does it take to commit an I/O. Now, we should be looking at a low number there. I would say that you should be under 20 milliseconds for that before you start getting performance degradation. And so we were getting from very low, like less than 1 millisecond, up to, the worst I saw was 500 milliseconds. And that's clearly not ideal. When we're talking about saving a document or closing an application, if each write takes 500 milliseconds, there might be 100 writes for all we know. Then that's not ideal. So during log-on time, as you might imagine, that was probably when it was under the most stress. And we'd get individual servers with averaging 40 to 50 milliseconds, and really people did feel the pain of that. So if you remember beforehand, I spoke about there being 5 EMC LUNs. We did a bit of a storage processor rebalance to try and distribute the load manually. But that didn't prove still to be enough. It did make it slightly better than that heat map that you saw, but it didn't improve it in such a way that our users were kind of running along and saying, that's wonderful, thank you for fixing everything for us. And so I think we needed to do something differently. So we had some discussions. I was involved not only in discussions about fixing this, but in discussions about what we would do with the acquisition of Equinet. And so having a foot in both tables, it was quite handy in the sense that I could not only see what was happening today, but what was going to happen going forward. And it was pretty clear that we might even have to go and buy a whole load of more disks, maybe upgrade our storage processors on the EMC, or worst case scenario, even upgrade the SAN. And clearly all those have a cost and an implementation cost associated with them. So we decided to do something a bit differently. So we spoke to some of our colleagues here at Atlantis in the UK. And I've known Jim, many of you guys know Jim Moore. I've known him for a very long time, since before his Atlantis days. And just in terms of a kind of Atlantis 101, what it basically does is it's a virtual machine that can sit on the major hypervisors, VMware, Hyper-V, or Xen Server, VMware in our particular case. And it takes some RAM and some disks, optionally, but some RAM in this particular case. And it presents it as either NFS or iSCSI. The reason iSCSI there is really about Hyper-V, but it takes it as an NFS export and presents it to the hypervisor. So what we're talking about there is effectively taking some RAM and presenting that as primary storage for our end users. And you can see with the graphs that are in front of you there, the kind of blue one and the red one, if you can put Atlantis in front of existing spinning disks rather than saying I'm going to take just RAM, you can do it. And you typically see a large reduction in the kind of back-end I/O that we require. And even in this case, with this RAM at the back end, the amount of I/O that the RAM needs to service is still significantly reduced by some of the techniques that Atlantis employ in order to dedupe that I/O and so on. So moving on to that, this is roughly what we did. You can see here the top layer, we've got individual XenApp server VMs. Okay, they are all. Let me come from the bottom. That might be a bit easier. Okay, there's a server, there's a hypervisor. On top of that, we installed an Atlantis virtual machine. And that Atlantis virtual machine only references RAM. Okay, it doesn't have physical disks that are in the line of primary storage. Okay, we have some disk attached to it for other reasons, and that's about something called snap clone, which I'll come on to. So what we did with those servers, the 2008 R2 ones with XenApp on top, is that we put the PVS write cache that was living on the EMC onto those. So rather than that going across the storage area network and onto the EMC, it's going directly into RAM. Now, it's not, we don't just put it into RAM natively. It all goes through the Atlantis engine, if you like. And Atlantis provides a number of techniques which reduce that I/O and improve the performance and the response back to the servers, and also vastly reduce the amount of RAM that you need to buy. So reading across those from left to right, application analysis is about understanding how applications do write and recognizing that certain applications like to write in certain block sizes in certain ways. I/O processing is knowing that we're effectively similar virtual machines make similar I/O patterns, and processing those and so making sure they only need to be written once or a small number of times rather than every single time that same I/O happens. Inline dedupe is about reducing the amount of storage that we need. I'll talk about the amount of reduction that we expect to see shortly. And then compression is about compressing that RAM to present more of it. And fast clone is about, if we wish, taking that RAM and taking that Atlantis appliance and the data that it has effectively and replicating it in real time to another Atlantis appliance, which can be held centrally, to allow us to replay that onto another server, which allows us to enable things like persistent Xen desktop, persistent XenApp, and what have you. The key point here is that we haven't changed anything in our architecture apart from where that E drive lives. We've installed an Atlantis ILIO appliance, taken some RAM, and put it in there. Clearly, there's a prerequisite of having some available RAM. Okay, I think that's a fairly obvious point. So if you're in a situation where you've got Citrix on your existing machines and you're not looking at migrating those hosts off, then you need to have some available RAM in them, which might need an upgrade or what have you. We'll talk about how much RAM that might be in just a minute. So there are some general rules of thumb for PVS write cache sizing, and in terms of laying physical XenApp servers out. So what we typically see on 6-core processors, we'll typically see 6 virtual machines today. Now there's been quite a few papers that have been written about this and sort of industry opinion. The guys over in Holland from Project VRC have written a number of these, and typically, I think they back up the idea that say if you've got 24 cores of processing power, logically, then 6 quad-core VMs is pretty well the way to go. Quad vCPU VM, should I say. In terms of write cache size, I think industry average based on this survey is 16 to 20 gig. Ours is actually 8 to 10 gig, but we also have an 8 gig page file. So page file management is quite important when we're putting things into RAM. Obviously, page files are relatively difficult to dedupe, and write cache is relatively difficult to dedupe. We'll talk about that in just a second. And so Citrix have a paper that is referenced down here, and don't forget, you are going to get these slides, that they reckon in terms of I/O sizing, it's actually 2 for light users, 2 IOPs for light users, 4 for medium, and 8 for heavy. I'm not sure that's quite right, and we'll come on to what we found in our environment fairly shortly. I think it's worth saying at this point that our end users are nothing special in terms of what they do. They are people that are basically coming in, logging into Office, logging into their CRM application, watching, going onto the internet, doing things like watching the tennis today. I saw a couple of people doing that. That's all done with Flash offload, though, so there's no great problem there. But in general terms, they're doing what average users do. We're not running extreme applications here, and we're not running particularly light applications. I'd say we're kind of medium users, which is probably the 4 IOPs measurement that Citrix have. But other than that, we're fairly well in line with what they do, with what Citrix would say. And so we made a decision to make a change. So you can see that the top level here, the production cluster, hasn't changed at all. The middle cluster's changed a lot. So we took 2 servers out of that middle cluster and put them effectively into an infrastructure cluster at the bottom to host our NetScaler, web interface, zone data collectors, etc. on there, things that weren't serving a direct XenApp workload. We added 4 new blades into the middle one, and we were going to terminate all of our write cache in RAM. So no connections to the middle cluster to the EMC anymore. And this meant a subsequent change to our PVS and write cache layout that look like this. So 2 PVS servers now, about 50 XenApp hosts. Don't forget we've got another 20% of users of service. And then the write cache just going into Atlantis ILIO. I'd say 10 to 12 hosts running ESX is 10 hosts that are basically running running XenApp, and a couple that are running the management services associated with it. So we have to think about what we do in the new configuration. This isn't gospel, okay? There are different ways to carve this up. This is what we spoke. This kind of sat down with a couple of the guys in our teams and said, what are we going to do? And so we bought 4 new blade servers that were a fairly similar spec, but with a slightly faster processor, because we can't really go and buy the older ones anymore. So we stayed on hex core. So rather than X5660s, we went for the E5s, which I think, according to HP, are 39% quicker. Not quite sure how they get such accurate stats, but that's roughly what on a per processor basis. They're about 40% quicker, but the same amount of RAM. But the reason we chose 6 core rather than 8 core is we wanted to try and get to a fairly standard server size in the layout. If we had our time again, we might have chosen 8 core in terms of value. I think if we're doing a new implementation for new customers, we recommend 8 core at that point. But we did this, and it's worked out. It's worked out for us. So with me talking earlier about running 6 VMs with 4 vCPUs, Atlantis does take a vCPU away from you. And so we want to be relatively conservative in what we're doing here. So we decided to run 5. So we didn't commit everything in terms of the vCPU. So we're running 5 hosts with 16 gig of RAM each, which left us a little bit more than 40 gig available for Atlantis. Now, the little bit more is effectively the memory overhead that ESX adds on to each virtual machine. So quad-core 16 gig of RAM servers, there is a table that you can follow on VMware's website about how much overhead that adds. But we were left with enough for, I think the maximum size we could have done without overcommitting RAM was about 44 gig of ILIO. We went for 40. Now, when I say that gives circa 46 gig available, 6 gig of that gets taken up by effectively the OS and the appliance, and then the other 34 gig gets compressed, remember all those features from earlier on, and presents a 46 gig drive that's exported as an NFS export within each host that we put all of our PVS write caches on. So those 5 20 gig PVS write caches go onto that 46 gig drive, and you might have noticed that 5 times 20 is more than 46. That's definitely true. And that RAM planning is something that you need to take into account with ILIO and with Atlantis. And the guys at Atlantis, like Jim in the UK and his counterparts in the US and what have you, have got some sizing calculators. We'll talk about our experience about how that works compared to what we saw in reality in just a minute. We also use Atlantis ILIO Center, which does some monitoring and reporting, allows us to do the simple deployment of these appliances. We went with an approach of putting effectively a Citrix template within each ILIO appliance. And that allows us to provision them very quickly by closing them if we require. Also, this bottom piece I think is quite important if you're considering doing this. I'd recommend that you go for a clean template in terms of that write cache drive. Don't just take a copy of an existing one, because there might be some junk on there that you don't want. You might as well start with the smallest possible footprint before you do this. And so that's what we chose to do. In terms of timescales, on the first day, we built 4 hosts with ESXi on it and deployed some VMs. It actually only took a couple of hours. Most of the time we spent was messing around trying to get the ILO to work and the HP Blade Center, but that's another story. Put simply, the ILIO, the installation of the Atlantis part, was maybe it's around 15 minutes per host, I suppose, from start to finish, not using automated deployment. Okay. What we decided to do on the first day was really just kind of test how this works and test out the functionality. So we took some VMs from one of the hosts and put them in the farm. Now, we want to be really cautious about that write cache sizing. If you think about that 3 times those 20 gig drives, there was only 40 gig of RAM available. We wanted to make sure that we weren't going to be pushing the limits. So we did that on one of the hosts. And on the other host, we tested a feature in Atlantis called Snap Clone, which allows us to take the state of those virtual machines while they're off and write them back to local disk. And the reason that's important is that, of course, RAM is, of course, volatile. And so if we just reboot that host, the Atlantis appliance would come up effectively, it would come up effectively as being empty in terms of our write cache. And we wanted those, and if you think about our write cache and all of our VMware VMX files and what have you, so we wanted that to be able to persist between reboots of the Atlantis appliance and therefore the host itself. So we used something called snap clone to kind of write those disks back down as we were doing that. So over the first week, we were pretty cautious. We measured the disk usage of ILIO. We scaled it to 4 VMs per host. And then we implemented something called sdelete. Now, this is in the Atlantis manual. I strongly recommend anybody that's looking at this to think about this. Sdelete is a tool written by Mark Rusunovich, which is part of the sysinternals toolkit that Microsoft acquired some years ago. And what sdelete does is it basically, you can use it to zero out blocks on a disk. So you can run sdelete -z on your master disk, if you like, on that E drive or on your write cache disk, and that will write all of the blocks that are marked for deletion with zeros. That allows Atlantis to dedupe them much more effectively. I strongly recommend you don't run sdelete without the -z. Then you can try it if you wish. What it'll do is wipe your disk. That's probably not the result that you're looking for. But sdelete -z, it's in some of the Atlantis papers. It made a big difference for us in terms of write cache sizing, in terms of the amount of RAM that we committed. We actually run sdelete by using group policy preferences within AD. And so we make it run every night. So if you like, over a period of a server being booted, the write cache grows and the page file writes grow. And some of those blocks are then marked for deletion as people log off or as things change. So we make sure that sdelete runs every night to keep that write cache size in trim, and to keep, well, it doesn't keep the write cache size in trim, it keeps the zero blocks zeroed so that Atlantis can do better dedupe. And so having got some confidence about having done this, we then scaled to 5 VMs on a host to make sure that our 5 VMs would sit comfortably within that 46 gig NFS export that we had. So week 2, we scaled this out to 3 of the hosts running 5 VMs. And then the fourth host we used some user experience testing. I'll come on to that in a minute. I think user experience testing is really important. There's no point in doing something if you don't prove it makes things any better. So getting buy-in from end users is pretty important. We use this to do some support and training for our guys that would look after the support of this going forward. And we did some monitoring of the disk usage and did a bit more tuning, kind of worked out what should be on that disk and what shouldn't. And by week 3, we'd put all the 4 new hosts in, and then in week 4, we took all of the existing 6 hosts as was and rolled it out so we had 10 hosts all in fairly identical configuration. We did some capture, some of it fairly manual, some of it very detailed, about log-on time under control conditions, log-on times under contention, key application launch time. Some of the things like, if you only use application streaming or app V caches and these things, they run really fast. They get cached in ILIO and they run super quick. So we saw some big changes there. We also were pretty keen to capture our storage performance before and after, and work out what the storage savings would be. If you want to capture optimum peak capacity, you can use things like edge site for load testing or login VSI. Edge site for load testing is not that much fun. I think it's being depreciated now by Citrix anyway. But these things will also allow you to work out how much churn there's likely to be in that write cache and how much of a problem, how much RAM that you need to commit. And so, anyway, on to the results. So like I say, we rolled this out in a fairly short period of time, and what I want to show you is what happened with the storage before and afterwards and what happened to our end users. So in terms of the EMC, the blue and the green on here represent storage processor A and storage processor B IOP handling. So the large peak at the beginning is people coming in at 9 o'clock. It starts building up from maybe around 8-ish and peaks at around 9. And then the peak at the end is 5 o'clock. The peak's not quite so high in terms of that bit there, but people are clearly leaving the building at some rate at that point, or they've logged off already, or whatever the case may be. I don't know if we took these on a Friday, then it might be a bit less than that. Now, I think what we're looking at here, this is all dated prior to the Equinet acquisition. At this period of time in the morning, the sort of 9 o'clock period, we're ramping up numbers of users. And the most number of concurrent logons we're seeing over, say, a 10-minute period is around 300. Okay. Whilst we're running in this busy period during the day, in terms of steady state, there's around 550 users, of which probably 450-ish are active at any one point in time. So 550 sessions, 450 active. Those numbers have gone up all by that factor, about 20% since the acquisition, but this data is from before then. So afterwards, it looked like this. Okay, so there's a reasonable drop, as you can see. The scales are still the same if you look before and afterwards. There's still some I/O on that EMC, but that's what's left after XenApp's done its bit. We're still seeing a peak at 9 in the morning. We're still seeing a peak at 5 o'clock in the afternoon. So what that means is, in terms of this, that's the amount of I/O on the same scale that was created by XenApp compared to the rest of everything else that was supporting us in our environment, with the exception of Exchange. Now, what that worked out in terms of my math was that during the day, in 10 to 4, when we're assuming that people aren't really logging on and logging off in any great quantities, we're averaging about 14 IOPs per individual session. Now that's based on about 450 to 500 users per session that are actually active within that environment. If you want to divide it by 550, which is the actual peak, it's marginally less than that, but they're still, well, it's still nearly double what Citrix count as a heavy user, and these guys aren't heavy. They're just doing normal work. During peak logon times, like I said, we get about 300 concurrent sessions in 10 minutes. That works out around 32 IOPs per user. Now, you might say, why not divide that by 450? The fact is we don't have, or 550, we don't have that many people logging on at once during that period of time. In everybody else's working environment, it may well be different to that. You might get 550 people logging on between 5 to 9 and 9 o'clock. Particularly for people like schools and classroom environments, they get many more of these I/O peaks. Okay. What we found them from the past, and particularly with BDI, and now also with XenApp, is that sizing to the average is nowhere good enough, and really sizing to the peak isn't good enough unless your users are very predictable. So the peak here is probably about contention rather than actually what end users want. Anyway, in the heat map earlier on, you were seeing there was some storage processor stuff, some utilization. You can see again, in the morning, this is average storage processor peaks. We're averaging over, well, 85% in the morning. That means if we have storage processor failure, we have some serious problems. But it also meant is that for certain periods of time, we were averaging 100% peak, which meant we get some LUN traversal and LUN failure between different nodes. And that's what was hurting us, I think, in this particular case. Afterwards, a large reduction again, as you can see. So before and after. In terms of the heat map, this is the heat map from beforehand. You can see pretty busy at the top. Dirty cache pages, they're looking sort of quite busy as well. What they basically are in terms of dirty cache pages are things that the EMC can return from cache rather than having going back to the storage natively. As you might imagine, that write cache data, there's not much it can return from cache. It's mainly write. So after that, you can see there's a big reduction across the board. This period at the end here is actually a backup window starting, so don't be confused by that. The cache pages have come down a bit, and they're probably working at roughly about where we'd expect them to be. SSD tier is no longer being thrashed. And in fact, there's a general decline in usage, as you might expect, across the entire SAN. So in terms of user experience, roughly down 40% logon time versus our SSD-enabled SAN. Application launch time down 30-40%, and that kind of gets better as more applications get used. Streamed apps launch time down by about 50% or more. Better consistency, I think, is the key thing for us. We didn't get any peaky performance, and then an increase. We also increased the number of users by 20% during this period of time, and genuinely there was time saved for our end users. What we found is actually they started moaning about other things more. They started moaning about Exchange not being very good, which is kind of fair enough, okay? But that's typically what they did. And there was a significant reduction in support calls. So if you remember, before we had January, February, and March there, so we implemented ILIO at the end of March, and so April and May we reduced those support calls down by a fair number. And the reduction really from April to May is about onboarding new users and then them getting used to the system. But you can see there's a kind of 65-70% reduction in the number of calls that we're expecting. And these are made up of the typical XenApp suspects of something under contention. Profile issue, that means it's slow. Session frozen, that means there's not enough resource for whatever reason. Application frozen, well, that's the same thing. An error message, well, that could be anything, frankly, but at least they went down. So in terms of the benefits for us, if they're not obvious, SAN performance. So we've now absorbing our Exchange workload into the SAN, and going to use that fast cache where it's much better enabled to do, much better utilized, such as on SQL or what have you. We've also now got SAN controller resilience back. If we lose the SAN controller, then we're able to run without disruption to the business. It's made troubleshooting things much simpler. So we found that there have been settings before, and I've seen other customers with this, that DRS had got turned on within a Citrix cluster, and we absolutely do not want that in the way that we configure these things. So with only having local RAM-based storage, that isn't even an option. It's not going to do anything. And so, we're not getting accidental DRS settings and that kind of stuff. It also means that we don't have troubleshooting issues between networking and storage and what have you. It's pretty simple. If the Citrix servers aren't performing, it's about CPU, it's about memory, or it's about it's about network. It's not about us being contended in a complex networking environment back to some storage. And I would say it was easy. It was easy for you to do, and it's easy for you to support. You just want to take a few of those lessons about running S-delete and sizing that right cache properly, but it's easy. So in terms of the number of disks required before and afterwards, if you take the RAID 10 look here, in terms of the adjusted IOPs that we required at the back end, 9 AFDs and 122 spindles, down to 5 and 59. If you took it in terms of RAID 5, which we may or may not recommend, 15 and 208 down to 6 and 75. So you can get a significant reduction in the amount of the spindle count that we require. And that's just shown graphically here. This required before, this required after. So were there cost savings from this? Well, yes, I think is the answer to that. We're in a situation where we were going to have to buy more AFD or more SAS bits. I kind of spoke to our EMC guys about this, and we reckon that around 50 SAS 15K drives have been required to support this without interrupting the rest of the business. So that means 4 more shells, and it probably means a new AFD tier in front of it as well. And so we didn't have to make those changes. We didn't have to implement that, and didn't have to put in more complexity into our SAN. We didn't have to upgrade the controllers. In terms of controller upgrades, I think we could have worked around that, but we don't actually know, is the truth of the matter. I think we could have worked around that with the extra SAS drives and what have you. But we don't know if we'd have had to upgrade them. At the very least now, we know that we can survive a complete controller failure with no downtime to the business. And there was even talk about SAN replacement at this point as well. We've avoided all those costs that we might have had to incur. Definitely the SAN's going to be used for longer, and definitely our users are happier. They're definitely not complaining about Citrix in the way that they were before. In fact, Citrix calls are now below what we'd expect for the user base that we've got. So, in summary, I'm just going to flip through all of these. There really is a measurable increase in user performance. We are talking individual servers that will hit tens of thousands of IOPs. The slowest part of this in terms of I/O now is the PBS write filter driver. I'll come on to that in just a second. Predictable scalability is nice. So I think probably a lot of people will be used to a kind of modular design for XenApp or a modular design for Zen Desktop or what have you, where we're basically saying, here's a building block of CPU, of memory, of what have you. In this particular case, it's CPU, memory, and disk, and so it's a scalable modular design. Buy less disk, or get more out of what you've got. So one of the options is if you've already got a well-performing SAN or what have you, then you can increase the lifetime of that or reduce the load on it. Don't forget, when you buy those disks for your primary storage in your SAN, you're not just paying for the disk, you're paying for the cost of backing it up, the cost of replication, all those kind of things that are built into the cost of what you're paying for there. Simple to install, simple support. Estimate memory usage, but please verify it. So the guys from Atlantis can definitely help you with that sizing, or we'll be happy to help you. But verify it to yourself, because everybody's different. Different people have different write cache sizes. Particularly watch out for people that use large files that go into that write cache, even if it's only temporary stuff. Definitely use S-delete initially and on a schedule. Schedule it with GPPs or something similar to that. Tune the write cache disk. Get rid of the rubbish that doesn't need to be on them. Don't start with something that's already broken. Measure everything you do and make sure you tell your users that it's better, because they won't come and run up to you and hug you and tell you that's fantastic, you fixed everything for me. Demonstrate what you've done and demonstrate that it makes it better. Better performance, I think I've said that enough times. And I think the key here is that RAM is very cheap. When there's some exceptions to that. Cramming RAM into old servers can be expensive, so it's always worth checking that out. But typically, certainly on new buy now, RAM is very cheap. Another slide in here about I think what's happening next for us. Clearly, we're going to move off XenApp 6, and we're going to go to XenApp, XenDesktop 7 App Edition. Not got really used to saying that. So but there's a few things that we want to do along the way, or at least evaluate. So but in terms of our SAN, we're going to move Exchange back onto it and do some tuning and some workload optimization where it's best fit. Now, there's some debate about whether we'll continue with PVS or not. We might use machine creation services from Citrix, so that's now an option in XenDesktop 7. We might use neither. We might use FCCM to do it and have persistent mode XenApp effectively, so no write cache. The biggest bottleneck that we've now found for memory is the PVS write filter driver. So there are options even within RAM-only technology to replicate persistent changes to disk centrally. And we're also going to make sure that we script the creation of everything within the farm. I don't know how well you can see this link at the bottom. I'd advise you to have a look at this. It'll be in the slides afterwards. Aaron Parker is one of the guys that works on my team. He's put some considerable effort into completely automated the scripted build of XenDesktop and then cloning it with ILIO to create VMs with zero cuts, all in RAM. Also, it's worth taking a look at what Jim Moyle's presentation, he's done a couple of presentations recently, one at Synergy, one at Bride Forum, about the I/O requirements for machine creation services versus Citrix provisioning server. It's quite enlightening and quite an interesting piece of work. I don't think that slide deck is publicly available, but get in touch with me or get in touch with Atlantis, and we can put you in touch with Jim and talk through what was done there. And with that, to be honest with you, that's about me done. Like I say, just take a look, take a look at XenApp. Even if you haven't got contended workloads at the moment, have a think about should they be on the SAN, should they be on local disk, should they be in RAM, and which one do you think will give you the best performance? And so that's it, really, from me.
Thank you, Jonathan. With the remaining time, we have several questions that have been submitted, so I'll go ahead and ask them in order and let you answer.
Okay.
The first one is asking you to expand a little bit more on the ability to use Atlantis both for the storage acceleration and extend that to the provisioning. So how would you use ILIO as part of an alternate way of provisioning XenApp VMs?
So it's something we've thought about. Certainly if you look at, take initially a look at, hang on a minute, let me go back to the bottom of that slide. That one there. If you take a look at that link, that's pretty well Aaron has done. Now, I'm not sure what the public status of the API to control cloning within Atlantis is. I don't know if it's something that Atlantis officially supports today. But what we've done there is use some PowerShell to effectively drive MDT to build our virtual machines, and then drive Atlantis to clone them. And that finishes the process for us. So from start to finish, we've got our gold image that's done by that. The maintenance of that would then expect to be taking place with something like SCCM, though you could do it with MDT if you were doing that, recreating and then cloning on the fly. It's something we'd be happy to talk about. The expert on that is Aaron, and he works for us. Have a look at that video, and then if you want to know some more about it, get in touch. I'm more than happy to take that in some further detail offline as well, if that's it. Seth, in terms of these things, how do we find out if I've actually answered anyone's question or not?
Yeah, no, that's a good answer. And we can follow up offline and provide all the questions if we want to get into more detail with someone. Next question is, as you were considering options for solving the problem, did you compare using Atlantis with your existing kind of HP and EMC infrastructure to switching to a kind of converged infrastructure, like a Nutanix or something like that?
So the answer is, in the timescales that we have, the answer to that is no. Now, Nutanix is a sort of scale-out infrastructure and provides a basically Fusion IO accelerated storage. Now, what we found with initial looks at Nutanix is that for XenApp, the costs don't stack quite as well. Now, there's nothing, I guess, to stop you using Atlantis in front of that and making that stack a bit better. But to be honest with you, the truth is that in the pretty much the month we had to fix this, the idea of bringing Nutanix in and moving to that architecture, it wouldn't have worked for us in those timescales, rather than any kind of technology challenges it would have presented.
Okay, thank you. A little bit more of a question around using RAM for the write cache. As you know, the question is basically, as RAM is so much cheaper, why not use RAM per virtual more RAM per virtual machine to reduce the Xen server reliance on the write cache?
Okay,
yeah, go ahead.
Okay, so we found that in testing, that even doing that, it doesn't make an awful lot of difference. Okay, even if we increase more RAM, we still get a lot of write cache churn, and we still get a lot of page file churn. Now, I'm not saying it isn't reduced, but the reason that we did this with Atlantis is because if you think about what we did with it, we had five drives per host that basically had 8 gig of page file and 8 to 12 gig of write cache. And that reduced that down to a requirement of 40 gig of RAM in that host. And that's the most horrible, difficult to dedupe data that there is. And it also means it performs faster than just native RAM, in the sense that we understand the application analysis and I/O processing, all that kind of thing does that job. Now, if you're going to buy things from scratch, you can do that. And of course, one of the PVS options is to use a write cache in RAM rather than a write cache on local disk. The problem we found with that is that you've really got to be pretty brave to do that, because there's no real reporting on how busy that write cache is. So I suppose, kind of answering your question, I hope, is that we found that even increasing the amount of RAM in the host didn't reduce the write cache churn as much as we would have hoped. Happily can do some further analysis on that. I know that Jim Moyle has done a bit on that as well. I believe he has. I've not put in words in his mouth. Put simply, we found that it wasn't as effective and it wasn't as cheap. Also, bear in mind that in the existing models that we had 128 gig of RAM, and that RAM wasn't cheap in that environment. In the sense that if we wanted to increase them, the RAM slots were already full, so we have to chuck them out to put more in. The new ones, it was simple. It was very cheap in those ones. Okay.
Okay, thank you. Could you talk a little bit more about, you touched on it, but a little bit more about the impact of your old density versus the new density in the new architecture, and how that might play out if you had different servers also, if you're doing it for a customer environment and with ILIO involved?
Sorry, so if it's a greenfield site, is that what you're saying?
No, I think cover both. So what happened in your environment relative to density per server, like XenApp sessions per server? Okay, and then if you were looking at a greenfield and building out a new environment for a customer, how would you look at the density?
Okay, so in terms of our environment, we are able to get more users per VM than we were previously. And that's pretty obvious, really, if you look at what was happening. What we found, though, in testing is that even in non-contended environments, we still get more users per VM, a fraction of maybe 10 or 20%, because the CPU usage in those servers is down because there's no disk queue. We don't get a disk queue on these servers anymore. If we monitor it over a day, we rarely get a disk queue above 1 in length, which is quite low on that particular drive. Now, in terms of did we set it up the right way, I think actually on 6-core servers, I think we'd still go for 6 VMs, and we'd slightly overcommit CPU if we're going to start again from scratch. And I'd expect that on those 6-core servers, we're going to get 20 users easy on a standard workload. In terms of new ones, the solutions that we're putting together now are typically based on 8-core. That's the kind of sweet price point. And in that environment, we'll have 7 or 8 virtual machines, each of which probably at least 16 gig of RAM. There are a couple of sweet spots for RAM price. If you don't go above the 16 gig DIMM sizes today, that's the best way to kind of maximize the revenues there. I mean, if you go into the larger ones, it really does get quite expensive. That's where RAM is not cheap when we go into kind of the latest cutting edge stuff. So I'd say on a new environment, we'll probably look at we have a sizing calculator that we use, but with modern dual 8-core servers, you're looking at a spread between 130 to 180 users on normal workloads. Those things get absolutely trashed if you're doing something that isn't normal. So that's a massive caveat at the back of that.
Okay, a follow-up to the question about the RAM sizing was that you wanted to know more around why not reduce the page file size and therefore use of write cache and its footprint, not simply increasing RAM.
So sorry, so it's reducing the page file size.
Yeah, why not reduce the page file size and therefore use the use of write cache?
So let's be absolutely clear. We can tune this further, and there's a guy called Nick Rintelin that works at Citrix that's done a really good paper on how to right-size memory in your Citrix servers. I'd strongly recommend people take a look at that. Now that's about working out what your kind of active payload of memory is, and then working out how much you might need to have in page file to work out what the right commit charge is. Now, in an ideal world, we would reverse engineer this and size the page file exactly. As it stands today, we use 8 gig on a 16 gig server. I wouldn't be comfortable going too low. I certainly wouldn't be comfortable going down to none. So I've had a couple of people suggest that to me. That sometimes tends to break things. But certainly we can get down below 8 gig on a 16 gig server, as you might imagine. How much further we can go down, it depends on your workload. It depends on your applications, because some applications will page stuff out whether there's RAM available or not. It also depends on whether you use tools like AppSense or whether to try and manage that RAM, because they can increase page file usage while lowering memory usage and so on. So what I'd say is that you can tune everything further. We found that this, in terms of a best guess in the timescales we had, was a pretty good sweet spot for us. So if you think about it, really we're taking 16 gig of RAM per server, and then we're taking each of those servers takes about 8 gig that uses from the ILIO appliance. If you take that 40 and divide it by the 5 hosts. So if we increase the amount of RAM and reduce the amount of page file, we're not going to save much anyway.
Okay, thanks, Jonathan. A couple Atlantis ILIO related questions, or one more, was asking if we support Xen Server, and if so, kind of what does it take to do that? And essentially everything that it's the same as everything Jonathan described, except there's a different package that you download that's for Xen Server support. In terms of, when you purchase the product, you'll download the Xen Server version, essentially, of the virtual appliance. There were several questions about the recordings and the slides, so I'll reiterate one more time. The recording will be automatically emailed to you within 1 to 2 days with a link if you registered for the webinar. And then the slides will be posted on atlantiscomputing.com on the XenApp product page. So with that, unless you have anything else you'd like to add, Jonathan, nope, we can bring the webinar to a conclusion. And thank you very much for all the detail about your XenApp implementation with Atlantis ILIO, and it was a great webinar. Thank you.